Chapter 8, simultaneous equations, systems of equations, otherwise known as systems of equations. Now, on these ones, you have to recognize what to do. You can either substitute, you can use the elimination method, or you can use the graphing method. Now, mostly we're going to use the elimination method, or elimination addition method, and the substitution method. Those are the two methods. Y equals x minus 6, and x plus y equals negative 2. This is a dead giveaway, because it has one variable in terms of the other, so that's begging for you to substitute. It's not always like that, but this one's begging for a substitution. Here we go. So y equals x minus 6 gets substituted into here. And I rewrite this. I go x plus, I create a pocket, and I put the x minus 6 in there. All right? And then I solve for x. So I've got 2x minus 6 equals negative 2. I add 6 on both sides. I get 2x equal to 4 and x equals 2. But I'm not done until I get the y as well. So how do I get y? Well, I go ahead and substitute that back into there. So I get y equals x minus 6. I guess I should really put it back into here. Okay? So y equals 2 minus 6, and we get negative 4. And our answer is 2 and negative 4. That's where these two lines cross. These happen to be linear equations, in other words, equations of lines, that if I were to graph that, if I were to graph this, I'm going to sketch this, that's all. This is not required in the question. They didn't ask you to graph it. But if I were to graph it, I would put all I know for sure is that at the point 2, negative 4, 1, 2, 3, over 2, negative 4, right there, that two lines, whatever the lines are, and I'm just kind of guessing what they're going to look like, are going to cross. Okay? And that's a real rough sketch. Remember, that bears only resemblance to this question in the sense that that's where they're going to cross. Okay? All right. Now, this one. This is a little harder. Why? Because it's not so clear what we're needing to do. And yes, there's a fraction, but we're having fractions. There's different ways to approach this. I would clear the fraction right at the top. That's what I would do. We learned how to do it. Okay, we learned how to clear the fraction. What would you do to clear the fraction?
Bowling ball method.
Bowling ball method. And what's our bowling ball? 2. Let's multiply the tops by 2. Clear the fraction and look at the problem again. All right, let's do it. So let's take our 2. Multiply it there. Remember, once you start rolling it down the lane, it's got to go down the entire lane. You can't just leave on one side. 2 goes into 2. That's what we want. One time. We're left with 1x plus 4y. Don't forget to multiply those together. Equals 18. Okay? Now, a whole new problem emerges. We still haven't really got a clear, we don't have like a clear substitution. What are we going to do to solve this?
Subtract 4y.
Well, no. Oh, we could do that. Yeah, we could actually subtract 4y, then substitute it. But we could also use the addition or elimination method if we multiply this whole thing by negative 4. Right? If we were to do this, okay, if I multiply this whole thing by negative 4, all right, remember that?
Yeah.
Then I'm going to get negative 4x. Look how I'm setting it up, right? I'm setting it up. Negative 4x minus 16y equals, oh boy, what's that?
Yeah, you can
negative 72. Okay, so now, guess what? We've set it up a certain way. That's our job. What happens when we add? That's why they call it the addition method, right? Or elimination method. What's going to happen when we add those?
You're left with negative.
They're going to eliminate.
They're going to eliminate. Eliminate, like all those teams in the playoffs, NBA, etc. They're gone, right? Now, not the Lakers though. The Lakers are going to win. So this ends up being negative 13y equals negative 65. Now all we can do here is divide by negative 13 on both sides, and we get y equals 65 over 13. That's it, unless you want to put it, or you can do this. You can put it in decimals, or you can do I think 4 or whatever it is, it's gonna be whole numbers. 5, hold on, oh my goodness, you know what that is? That's equal to 5.
I knew it.
Look at that.
You confused me.
I didn't recognize that 13 times 5 is equal to 65. So y equals 5. And we're not done. Because you need to get x and y. We've only found one part of the solution. Now, what do you do to find the x part?
Plug it in.
Plug it back in. We can plug it into any one of these equations, but we'll plug it into x plus 4y equals 18. All right, we'll plug it into this one. And this is going to go in for y, so this is x plus 4 times 5 equals 18. X plus 20 equals 18. Subtract 20 on both sides. And x equals negative 2. And we're done. Because we found negative 2 and 5 as our point of intersection. That's where those two lines are going to intersect. That's their solution. Okay? So that one was a little more complex, but same idea.